Hello everyone, my name is Foroozan Arkian. I'm a PhD candidate at Florida University. This is a part of my thesis project, and the title is Impact of Seaweeds on the Emitted Pollutants from Oil Refineries in the Gulf of Mexico, Costa Rica. Dr. Esmail Mori is my advisor. And thank you so much for being here and for this presentation. You can see here in the map. Okay.
Excuse me, you don't have a mic on.
Let's go. Thank you. Okay, this map shows the location of refineries in the US, and you can see here. The most of refineries are located in the Gulf of Mexico. We have two largest refineries in the United States in this area, the Motiva and Valero refineries. For the several years, some of these refineries emit unauthorized air contaminant into the environment. We define three study regions based on the distribution of refinery in the Gulf of Mexico, Costa region, GCR. And this presentation will focus in region 2 because, as I said before, sorry.
The pointer doesn't work.
It doesn't work. Okay. Okay. In the region 2, we have two refineries, the biggest refinery. This is the Port Arthur region. The another one is Houston area. The first region is the Houston area. The second is Port Arthur. And third one is the Louisiana. We have about 150 refineries in the Louisiana. And the name of this area is Cancer Alley because of the risk of cancer is very high in the Louisiana. But in this paper, I'm going to talk about the region 2. Okay, in region 2, we have two biggest refineries. One of those is Motiva and another one, Valero. You can see the health risk score is very high for Motiva compared to all refineries in the Texas and also all refineries in US. The risk score is, health risk score very high. The same thing for Valero refineries. The Valero refineries by itself, the risk score, health risk score is higher than Texas and also US as well. This is the location of Valero and Motiva oil refinery. You can see they are very close to Gulf of Mexico, and daily wind and precipitation variability in the GCR is heavily influenced by land, sea breeze circulation. You have a circulation, atmospheric mesoscale circulation, sea land breeze, and this is impacted by this circulation. Here I bring two pictures of sea breeze and land breeze. You can see during the day we have sea breeze because of the difference capacity heating of land and sea. There's a circulation, and it's happened during the day from the sea. And for the night, we have a breeze from the land to the sea. And this interaction, we hypothesize that the associated wind variability and convergence zone of sea breeze play an important role in the concentration and transport of the pollutant released by the refineries. The goal of this research is develop a better understanding of the transport and fate of pollutant emitted from refineries along the Gulf of Mexico Costa region. And the result of the research question is, what is the concentration and spatial distribution of NO2, SO2, and CO pollutant at different distance and direction from the refinery? And what role this sea breeze process play in determining the concentration of the pollution emitted from oil refinery in this study region? This picture shows the propagation and influence length of the sea breeze. you can see the sea breeze goes to the land, and there is an influence length, and we want to know how these sea breeze interact with the air pollution that comes from the air refinery. Sorry. Okay, we can find the influence length by using radar, and also we can use this equation. In this equation, the influence length depends on the different temperature between land and sea. And this one is this circulation of the sea land breeze, and this is the length of penetration. The half of this is going to be the penetration length of sea breeze to the land. This is the location of the station, in different area, Houston area, Port Arthur, and also Louisiana. We selected 2 different stations, station 1, 2, 3, 4, and 5, and 6, because for finding the influence length, we need to know the temperature and also speed of wind. That's why we selected the station data. And finally, we find that about the penetration length is going to be about 20 kilometers for series. And we estimated the influence length about 20 kilometers. That means the transport and freight of pollutant released from refineries could be influenced by the series, because the refineries are located in this distance that they can interact with the air pollution. And this diagram shows diurnal variability of sea breeze. The blue one is the wind direction. The green one is the air temperature, and wind speed is the orange one. We can see a sharp shift in the wind direction from the north to the south when sea breeze started. Sea breeze started. Sorry, can I go more? Okay, sea breeze started about here. 5 UTC, and if you change it to central time, because the location is central time, 6 hours before that, and it's gonna be 11 o'clock, 11 a.m. The sea breeze started, and it's continued by the end of the day, and then the same pattern happened for the next day. Air pollution modeling. In the part of air pollution modeling, we use the WRF model to downscale the data, because the sea breeze mesoscale phenomenon, and we cannot see with the other data with the coarse resolution. That's why we downscale the data from the domain 1, about 27 kilometers, to 9 kilometers, and then 3 kilometers. The finest that we find about 3 kilometers, every 3 kilometers, we have one data, and we can resolve the sea breeze in the location or in the region. And okay, when we downscale GFS data about the half a degree is about a 55 kilometer resolution. We change it to 3 kilometers resolution. We can see the location of the convergence zone that with the sea breeze very easily, and resolve the sea breeze and its convergence zone. And the next step is the AirMod model. We use AirMod model to find the concentration and also distribution, the pollutant in the area. This is the dispersion model that used for just for 50 kilometers, and more than 50 kilometers, we are going to use another model. The name is CalPop. We want to use the WRF model output as the input of CalPop model to find the distribution and the concentration of pollutant around the refineries. And when we run the AirMod model, we find this concentration for 2 boilers. You know, in the refinery, we have several boilers, we have several tanks, and we need to model all of those. We need to get get all of the data, to have all of the data to run the model. But for this paper, I run just for 2 boilers. One here, both of them are in the Valero refineries, and after running for 1 day, every hour run after 1 day, we find the maximum of concentration about 12 kilometers to the west of the 2 boilers. Okay, this is the National Ambient Air Quality Standard table, and the CO 8 hours standard is 10 milligram per cubic meter, and also for NO2, SO2. And finally, we found the concentration of pollutant about CO 4.45, NOx about 0.9, and SO2 about 0.8. This is the concentration that we find in the west of the refineries, the west of the 2 boilers, and this is the just for 2 boilers, not more. Because if you check, if you check this with the table that I showed you before, let me back. Sorry. Okay, for example, for NO2 is about 100 microgram per cubic meter, but we find I went back. I'm sorry. Let's start over.
Yeah, you gotta have the
You went too far.
Yeah.
You have to be patient with your key presses.
Sorry. Yeah, everywhere. Yeah, just last one.
Maybe you should just finish it and break from those.
Okay. Yeah, maybe. Okay, thank you. Okay, for conclusion, the influence length of sea breeze is estimated between 25 to 30 miles. Sea breeze circulation most often occurs during the summer and the spring. Sea breeze start around 9 a.m. Central Time and last by end of the day on August. The concentration that I said before is about 4.45, 0.9, and 0.8 microgram roughly per cubic meter. Not working.
Thank you, Foroozan.
Okay, thank you.
We have time for a couple of questions.
Yeah, I mean, great talk. So one of the things that I've seen is there's a contribution from the land breeze back onto nighttime pollution. Have you thought about that and how much that would impact the city? Like the city's own pollution coming back in?
From the sea to the land.
No, yeah, back from the, the
back
pollution that
from-
goes from the land to the sea that sits there and gets more pollution, kind of gets sucked back into the city. Adding to its own pollution.
Yeah, we just work on sea
Okay,
breeze
so you
and
didn't look it
not land breeze, yeah, not just that side. Yes.
So I was just wondering if you could tell us exactly how what you found out the concentration compared with the national standard.
Compare. You want me to compare?
Yeah, like how was your concentration, right? You found compared with the national standard.
Okay, the concentration here is very lower than national standard air quality, and because the national this is for whole refineries. If you run whole refinery, I can give you a quick tour maybe here.
That's slide number 19.
Is that? No, it's not working. Okay, yeah, I want to give you a quick tour about the refinery, inside the refinery. If you see the inside the refinery with the Google it, and you can find there is a lot of boiler, there is a lot of tanks, and there is a lot of flares, and they all have emissions, and we have to get all the emission from the different stationary sources. And then when you find everything, we can compare it at that time with the national ambient air quality and so on. But not now, because it's preliminary result that just for 2 boilers. That's very low, I know, that's so low.
Well, thank you, Foroozan. We have to move on to the next.
Okay.